Hey everyone, and welcome! Today, we're going to uncover something amazing, the hidden mathematical blueprint of the natural world. I mean, from the tiniest seed to the biggest galaxy, it really seems like nature has a favorite language. And that language is numbers. You can see it, right? In the beautiful, spiraling chambers of a shell like this. Each new section gets a little bigger, but the overall shape, it stays exactly the same. It's just perfect. And it's not just shells. We see it in the incredibly complex, repeating branches of a tree covered in ice. See how each tiny twig kind of echoes the shape of the whole branch? It's that pattern again. And get this, it's not even just in living things. We see it in the non-living world, too. I mean, look at the flawless geometry of a crystal like this. Just stunning. So all of this brings up a really big question, doesn't it? Is all this beauty random? Is it just a happy accident? Or is there some kind of hidden code, a mathematical blueprint that everything in the universe is following? All right, let's dive in and start looking for that hidden code. We're going to peel back the curtain, so to speak, and check out the fundamental structures and numbers that build, well, everything around us. Okay, so our first clue, it comes from the very basics, how things actually grow. And this applies whether they're alive or not. Okay, just look at this incredible pyrite crystal. Now, a jeweler didn't cut or polish this thing. Nope, it grew this way, literally atom by atom, building itself into this almost perfect dodecahedron. You know, a shape with 12 flat faces. It's simply following the strict internal rules of chemistry and physics. Wild, right? Now, what's really interesting is that even something super complex and alive, like this tree, it follows its own set of rules too. You see a main branch splitting into smaller ones, right? Well, that happens at very specific angles, and it repeats that pattern over and over again, all to get as much sunlight as possible. And this right here leads us to a pretty mind-bending concept, self-similarity. This is the whole idea behind what we call fractals. Basically, it means if you zoom in on one tiny piece of something, it looks almost exactly like the whole thing. And this is a perfect illustration of that. See this single branch on the right? Its pattern, the way it splits into smaller and smaller twigs, it's like a perfect little miniature of the whole tree on the left. It's like nature is being super efficient, just reusing the same simple rule at every single scale. So, okay, we've got rules for angles, we've got rules for shapes. So, what about numbers? Are there rules for numbers too? You bet there are. And there's one pattern that shows up way more than any other. You can actually find the answer if you look really closely at something like this sunflower, at those mesmerizing spirals of seeds. Now, this isn't just to look pretty. That pattern is the absolute best way to pack in as many seeds as possible. And here's the cool part. If you actually counted the spirals going one way and then the other, you wouldn't just get random numbers. Nope, you'd find numbers from this exact sequence, the Fibonacci sequence. It's probably one of the most famous patterns in all of math. And the way it works is, well, it's shockingly simple. It's this super simple repeating rule that's the key. You just add the last two numbers to get the next one. That's it. And that simple process creates this infinite sequence that just shows up everywhere. In the petals of a flower, the branches of a stem, the spirals of a pine cone, again and again. But wait, it gets even cooler. The real magic happens when you stop looking at the numbers themselves and start looking at the relationship between them. So, what if you divide any number in the sequence by the one that came right before it? Well, something pretty amazing starts to happen. As you go further down the line, that ratio gets closer and closer to this one very special number, about 1.618. You've probably heard of it. It's called phi, or the golden ratio. It's a number that artists, architects, and mathematicians have been obsessed with for centuries. And speaking of that famous ratio, that brings us to one of the most iconic examples of math in nature. But, as it turns out, it's also one of the most widely misunderstood. I'm talking about the nautilus shell. I mean, come on, it's the poster child for the golden ratio, right? For decades, everyone has said it's a perfect real-world example of a golden spiral. You know, where the curve expands by that 1.618 factor every time it turns. But is that really the whole story? Well, when scientists actually sat down and measured these shells, they found something else entirely. The surprising truth? It isn't.
The reality is a little more complex and honestly, way more interesting. The nautilus shell does grow in this gorgeous curve called a logarithmic spiral. That just means its shape stays the same as it gets bigger. But here's the kicker. When they measured it, its growth ratio is usually around 1.3, not that famous 1.618. So yeah, it follows a mathematical rule, just not the one we all thought it did.
So what does that all mean? It means that even if some of the popular stories are myths, the basic idea is more true than ever. Nature is absolutely using math as its fundamental toolkit to build everything we see. I mean, think about it. In just the last few minutes, we've uncovered this whole hidden language. We've seen the perfect geometry in crystals, those repeating fractal patterns in trees, the Fibonacci numbers popping up in flowers, and the beautiful logarithmic spirals in shells.
And this isn't some new idea. We're talking centuries ago. People like Galileo realized that if you want to understand the universe, you first have to understand its language. And that language, whether you're talking about a planet's orbit or the veins on a leaf, is math.
So the real takeaway here is that this code, this mathematical blueprint, it's literally everywhere, just hiding in plain sight. So next time you're outside, I want you to look a little closer. Look at a fern, a snowflake, a spider's web. The code is right there, just waiting for you to find it. The only question is, what patterns will you find?